This video is on topic 18, SAS and SSS. These are two ways we prove triangles congruent. If you recall, two triangles are congruent if and only if their corresponding sides and corresponding angles are also congruent. This definition states that all 6 pairs of corresponding parts of two triangles are congruent, then the entire triangle is congruent. This is really a long way to prove two triangles are congruent, matching up all 3 sides and all 3 angles. However, it is possible for us to prove two triangles are congruent using fewer pairs of information. Okay, you can think about these as shortcuts to congruence. Okay, so the first shortcut we have is side angle side congruence. What this states is if 2 sides and an included angle of one triangle is congruent to 2 sides and an included angle of another triangle, then we can say that the full 2 triangles are congruent. So again, the shortcut is if I can show that 2 sides and an angle that falls between them are congruent, that's enough information for me to say that the entire triangles are congruent. If we look at our diagram, what we're saying here is that if RS is congruent to XY, if we can say that angle S is congruent to angle Y, and we can show that ST is congruent to YZ, then we can say that the full triangle RST is congruent to triangle XYZ. Please note the order of the vertices. RST matches up with XYZ, following the same order like we had talked about before. Okay? Side, angle, side congruence. The next shortcut we have is something called side-side congruence. This states that if 3 sides of one triangle are congruent to 3 sides of another triangle, then we can say that the entire 2 triangles are congruent. So again, instead of doing all 6 pieces, if we can show that all 3 sides of a triangle are congruent to all 3 sides of another triangle, that's enough information. So here I'm saying AB is congruent to DE. We're showing that BC is congruent to EF. And we can show that AC is congruent to FD. Then we can say that the full triangles ABC is congruent to triangle DEF. Let's see what that looks like in practice. On our practice page, we are going to go ahead and, for each pair of triangles, tell which postular theorem, if any, make the 2 triangles congruent. Okay, let's zoom in on our first example. From our triangle, we can see that we have side XY congruent to side ML. We see that side XZ, the 2 tick marks, is congruent to side KM with the 2 tick marks. And we see that YZ, 3 tick marks, is congruent to side KL. I see that I have 3 sides congruent in one triangle, 3 sides congruent in the other triangle. These triangles are congruent by side, side, side triangle congruence theorem. Okay. In contrast, triangle EFG versus triangle LMG, I see that side EG with 2 tick marks is congruent to side GL with 2 tick marks. I see that side MG is congruent to side FG. Now, it looks like I only have 2 pairs of information. However, we could recall that angle G and this angle G, so FGE and MGL, are congruent by vertical angles. Vertical angles. With that piece of information, I now see that I have 2 sides and an angle between them. These triangles are congruent by side, angle, side. As we move on, we're going to see vertical angles and other properties pop up, things we need to physically add to our diagram to help us state one of the triangle congruence theorems. We're going to be recording them along the bottom as we go. Next 2 examples. We see in our diagram we are given RQ, 2 tick marks, is congruent to QZ, 2 tick marks. We also have another set of vertical angles. RQS is congruent to ZQX. However, we only have 2 pieces of information. This is not enough of a shortcut in order to prove triangle congruence, so this is not possible. Not possible to prove the triangle is congruent without more information. Not possible. Last problem on this row, we see we have WX with 2 tick marks and YZ with 2 tick marks. We also see this angle WXY is congruent to ZYX. And it looks like, again, we only have 2 pieces of information. However, I'm going to go ahead and highlight the 2 triangles, WXY, WXY. So we see this green triangle, and we're trying to compare that to ZYX, which is this light blue triangle. Now, if you notice, these 2 triangles share a side. That side is side XY. We can see that in the congruency statement as well. Well, if this side is in both triangles, technically it is congruent to itself. Technically, it is congruent to itself. So therefore, looking at our diagram now, this is called the reflexive property. Reflexive, like it's a reflection of itself. So this shows up whenever we have triangles sharing a side. This segment is congruent to itself by the reflexive property. Looking at our 2 triangles, we have 2 sides and an angle between them, 2 sides and an angle between them. These triangles are congruent by side angle side congruence. Next 4 examples. Look at these 2. It states that M is the midpoint of BC. So we see that we have a right angle, and this is a right angle. All right angles are congruent to each other. If M is in fact the midpoint, we know that BM is congruent to MC. So we have definition of midpoint allows us to say these 2 segments are congruent. And once again, we see that this segment AM shows up in both triangles. So this is congruent to itself by the reflexive property. So out of nothing, we've seen that we have 2 triangles, 2 sides and an angle between them, 2 sides and an angle between them. Now it is a right angle, but we still have 2 sides and a right angle between them. So that is in fact going to be triangle congruence, side angle side. In the next example, we see from the diagram we are given that LK is congruent to itself. We can also just kind of see that. Perpendicular bisector is the key phrase here. Perpendicular meaning that we form right angles. Okay, so definition of perpendicular. First piece of information. Again, we're given it, but we know the definition means that we have 90 degrees. The other piece of information then is the idea of the definition of bisect. Bisect means it cuts a segment in half. So that means that MK is going to be congruent to KG. Once again, we have an example of triangle congruence, side angle side. Okay. Last 2 examples. We are given triangle FGE, triangle RQS. If I'm looking at the triangles, it looks like I have enough information. We have sides, 2 sets of sides congruent, 2 tick marks and 2 tick marks. And we also have an angle congruent in each, angle E and angle S. However, further inspection, triangle FEG, it looks like it's set up for side angle side. While as down here, it looks like we have side-side angle. These do not match, so therefore this is a not possible to prove these triangles are congruent. There is no such thing as side-side angle congruence, so this triangle cannot be proved congruent. These 2 triangles cannot be proved congruent in their current state. All right, last problem, we see WX congruent to XZ. In the given triangle, in the given diagram, we also have another side congruent with the 2 tick marks. Since we're looking at triangle WXY, which is this black triangle up top, compared to ZXY, the bottom triangle, we see this segment is congruent to itself by reflexive property. So therefore we see side, 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 triangle congruence, three sides, proving the congruence of the two triangles. Okay. The other style of problem that we can ask with triangle congruence is to state additional information that is required in order to show the two triangles are congruent by a given theorem. As an example, the first section here, if I want to prove these two triangles congruent by side angle side, well, from the given diagram, I know I have two sides being congruent. I have side SR and side GH, and I have side IH and ST. So a quick little note, the only thing I need now is an angle, and specifically this angle needs to fall between my two sides. So here we're looking for angle IHG to be congruent to this angle, which is angle TSR. Okay. Looking at the one below it, I want to prove with triangle congruence side, side, side. I'm given two triangles, two sides, sets of sides that are already congruent. Side WV congruent to side DE, and EF congruent to side UV. Well, if I have two sides, that means I'm missing a third side. In this case, we're looking for our third side to be WU congruent to DF. The last two examples are done very similarly. I'll leave those for you to do. Thanks.